Okay, this lesson is 4.2, comparing numbers. Continuing on with the scientific notation. Your I can statements, you'll be able to say I can compare quantities written as the product of a single digit number and a power of 10 by stating their multiplicative relationships. Alright. Now yesterday when we talked in 4.1, we brought up this instance where in science you see this a lot of time. You see the scientific notation in your science notebook. When looking at this, it asks, okay, which planet has the largest diameter? All right, here's the different planets. Here's the diameter. All right, the diameter is with the cross. Which one has the largest diameter? Well, kind of hard to tell by looking at this. First thing you need to do is go right here and look at the base 10 and look at that exponent. Which one has the largest exponent? Well, you've got 4, 5, 5, 4, and 3. So we know that this one and this one are the largest so far because they both have the 5, the largest exponents. So now we have to look right here. What are we multiplying times that base 10? Which one is larger, 1.429 or 1.205? Well, 1 in 429 thousandths or 1 in 205 thousandths. This one would be your largest one. So which planet has the largest diameter? It would be Jupiter. Letter B. Which of the listed planets have a diameter less than the Earth's diameter? So now you gotta erase all this. Now we gotta look at the Earth. The Earth's diameter is right here. Which one has less than 1.28 times 10 to the 4th? Well, we have to look at the ones that have less than a 4. We know these can't be it because they're bigger. They've got the 5s. Now possibly the 4, 10 to the 4th power, 10 to the 4th power. We're going to have to look here. Is 1.21, think of it as money, $1.21. Is that less than $1.28? Yes, it is. So this one is less, so we're going to put Venus. And what else is less than the Earth? Well, this one has an exponent of 3, so it doesn't matter. Even though 2.3 is bigger than 1.28, it has a smaller exponent, so it's still going to be smaller, so also Pluto. All right, now let's go on. Comparing using less than or greater than. And remember, less than, hold up your left hand, makes the L, the less than sign. Just a reminder. Now there's a couple ways we can do this. Notice we have one in standard form and we have one number that's in scientific notation. Now some people would rather change this into scientific notation. Other people are like, no way, I'm totally changing this one into standard form. Well, you know what? You get to pick. Alright? But for the video's sake, I'll do some of each. On this one, I'll change the scientific notation into standard form. So my decimals here, move it 3 times. I'm going to get 2700. I moved it 3 times. I now have 2,700. Now I can easily tell that that is smaller than 27,000. So this is smaller, gets 1 point. This is bigger, gets the 2. We connect. So 27,000 is greater than 2,700. Letter B. Now here, I don't even have to switch one or the other. They're both in scientific notation. All right? Now it's a little bit harder to tell, but they both have the same exponent of 8 and 8. So now we're going to have to go back here and look. The number we're multiplying. Now which one's bigger? Well, if I move it over here, 1.5 or 1.15, you can add, remember when you line them all up nice, I can always add this 0 here so I can see. Now, is $1.50 bigger or $1.15? 1 and 50 hundredths or 1 and 15 hundredths? Well, obviously this one's the bigger one, and that one was 1.5, so this one's here, smaller one here, so it is a greater than sign in that one. Letter C. All right. Now here, let's see, what did I do? I traded this one in to standard form. So on this one, let's change to the same, let's change this one into standard form again. If we change this one into standard form, oh wait a minute, I'm in the wrong one. My bad, sorry. Here we have, all we have to do is look at the exponents on this one. I was on letter D. This one has a -3, this one has a +3. They're both in scientific notation. I don't need to do anything for that. All right? All I have to do is tell myself that negative is always going to be smaller than my positive. So this is smaller, this is larger, you have less than. Okay, letter D. Okay, so change to the same form on letter D. Let's move this one. This will be 9.31 times 10 to the -1 power. There we go. All right, now looking at that, I switch this one into scientific notation. Now, -2, -1. Be careful, don't let the -1s fool you, all right? We know negatives are smaller, but which one is smaller? The -2 or the -1? The -2 is smaller, so it is less than. Because let's look, if we left this one as 0.931, and say we change this one, 1, 2, we'd have 0.931. So we'd have 931 10,000s, 10,000s, and here we'd have 9,310 10,000s. So this one is way bigger. All right, and the last one, E. All right, so looking at this, what you want to do, let's turn this one into standard form. So -4, 1, 2, 3, 4. So I'm going to have to add 3 zeros. 1, 2, 3, 5, 1, 6. Now, which one's bigger? 1, 2, oh, this one only has 1, 2, 3 zeros, 4 zeros, and this one only has 3 zeros. So which one is smaller? The one with the 4 zeros here is smaller. So that gets 1 dot. This one's larger, greater than, and we have greater than. All right? Now let's say we turn this into scientific notation. This would be, I'd have to put my decimal right there, so it'd be 5.16 times 10 to the 1, 2, 3, 4, 5, -5 power. All right, now you look at the exponents, -4 and -5. -5, it's opposite day when it's negative, so that one is smaller. So either way you do it, you can come up with the right answer. You pick which way you like to turn them. Next page. All right, so like I was talking, you pick what you want to do for letter A. Now, we have standard form and 2 of them in scientific notation. So myself, I think I'm going to turn this one into a scientific notation. Then I only have to change one of them. All right, so oops, hang on 1 second. All right, back to this one now. So we'll put our decimal there to make our number that is greater than or equal to 1, but less than 10. So we'll have, this will turn to be 2.17 times 10 to the 1, 2, 3, 4, 5th power, and it's a positive number, right? Because our original number was a whole number, not a decimal. So now we can compare decimals. Exponents. We have a 5, a 4, and a 5. And now we have to list these from least to greatest. So I can look at this already and know that this one right here is my smallest one. So I'm going to put that right here. 2.1 times 10 to the 4th power. That's my smallest number. All right, so we're done with that one. Now we need to look at these two. Which one's smaller, 217 or 271? Because they both have an exponent of 5. If you get confused, think it is money. Which one's smaller? $2.17, $2.71. It is, this one is the next smallest, but you have to use the original. Okay, so use your original up here, which is 217,000. Okay, and then this one is third. This is the largest, 2.71 times 10 to the 5th power. That one's done. All right, now I'm going to look at this one. I see that I have 2 of them here that are in scientific, so I'm going to turn this one into scientific also. It's going to have to go right there. So that will be 8.42, that's my new number, times 10 to the, now this is, the original's a decimal, so I know it's going to be negative. 1, 2, 3, negative 3. All right, now we're looking at our exponents, and they're all negative 3s. So they're all negative 3s. So go back, we look at the number that we're multiplying. Put them in order from least to greatest. Now 8.4 is 0. You can add a 0 there to figure out, to compare them. Which is the smallest? The smallest one technically would be 8.24 if it wasn't a negative. But it's like opposite day when it's negative, so since this one would be the smallest if it was positive, that one is now our biggest. So we're going to put that here. All right. Now, which would be the next one? 840 or 842? All right. Which one would you go with? You would go with 8.4 times 10 to the negative 3. All right. And then this one, the original, 0.00842. This one is your smallest one. All right, so they're in that order. All right, now we go to letter C. Now we have 4 of them to compare instead of just 3. What do we want to do? Well, let's see. Well, if you look here, what do we have? They're all 1.5, 1.5, 1.5. They're all in scientific notation, so all we have to do is look at our exponents. The smallest exponent. Well, it's going to be one of the negatives. Which one's smaller in the negative world? The negative 4. So we're going to go 1.5 times 10 to the negative 4. That's my smallest. Next will be this one. 1.5 times 10 to the negative 2. And then what's smaller, obviously, out of the 4 and the 8? 1.5 times 10 to the 4th. And then this one would be the largest. 1.5 times 10 to the 8th power. And then we have 2 more here. 62,000. We have 1, 2, 3, 4 numbers again now that we have to switch in. Now this one is not really going to matter either way because you have 2 of each. You have 2 scientific notations and you have 2 standard forms. All right? So I'm going to, let's see, what do you guys want to do? Let's switch these into scientific notation. 6.2 times 10 to the 1, 2, 3, 4th power. This one turns into 6.12, I'm right so far, times 10 to the 1, 2, 3, 4, 5, 5th power. Okay, now we can look at our exponents. We've got a 4, a 6, a 4, and a 5. So we know that the smallest ones are going to be these 2, right here. Now you ask yourself what's smaller. Now they're all positive, so which is smaller, 6.2 or 6.12? This one is smaller. So 6.12, $6.12 is smaller than $6.20. All right, times 10 to the 4th. So then we put our original, 62,000 would be next. So those are done. Now here, 5 and 6, which is smaller, the 5. So we put our original, 612,000, using commas with all these zeros, all right? And then finally, the largest one, 6 0.2 times 10 to the 6th power. All right. All right, and now we have the last one that we have left. Now this one's a little trickier because we've got a negative here, and we've got a negative here, and a positive. So I think what I'm going to do is I'm going to put these all into standard form, so it's a little bit easier to see which ones are the smallest and the biggest, because standard form is a little easier to see. So this one will turn into a negative. Move this 5 places, so 4, and then 1, 2, 0, 7, 3, 4, 5. So you get a negative 407,000. This one is already in standard form. Let's move this one. You're going to have 4, 0, 7, 1, 2, 3. So we moved it 1, 2, 3, 4, 5 places. So we end up with 407,000 positive. Over here it was negative, right? And then here this is in standard form already, a negative 0.04. Just a little bugger there, all right? And even a littler one here. Because now we know that our negatives are the smallest ones, and it's like backwards day for negatives. You would think, you know, if the negatives weren't there, 0.04 would be your smallest versus 407,000, but it's negative world, so it's opposite. So the smallest one actually is what? The smallest one is the biggest one, okay? So right here, you can use the original, negative 4.07 times 10 to the 5th power. That is your smallest one. Then we go to this one, because this one's closer to 0, so it is bigger than this one, since this one's closer to 0. A negative 0.04. Then the next one, which one is smaller here? 40,700 is definitely smaller than 407,000. So here's our largest one at 4.07 times 10 to the 5th power. 4 and 700ths. All right, your homework for tomorrow, you need to do pages 3 and 4 in your homework in your packet. All right, because then we're going to be having a quiz the next day on our 4.1 and 4.2. So homework is pages 3 and 4 in your packet.